This is your 10.3 lesson, and we will talk about our Earth. Why is it habitable? Greenhouse gases, as well as climate change. So our Earth's atmosphere allows us to have a habitable planet. We have climate is long-term pattern of our regional weather patterns. So we were talking about weather before. Weather is our daily occurrence, what's happening from day to day, hour to hour. And now when we're talking about climate, that is more of an overall pattern of that weather within a certain area. So certain regions of Earth have different types of climates depending on their location, and most of that allows for us to have life. Our atmosphere allows for 50% of our solar radiation to be absorbed by the Earth's surface. And then we have another 50% that either gets reflected, scattered, or absorbed by water vapor or atmospheric gases and the ozone.
So the reason that we are able to have this habitable types of climates on our planet is first, we have to get that 50% in, right? So how do we do that? And that has to do with our atmosphere. And it really is our atmosphere that allows for that habitable climate to exist on our planet. Sometimes referred to in astronomy as the Goldilocks zone in terms of our distance from the sun. And what happens is our atmosphere has the ability to not only allow radiation to come in, but it also allows that radiation not to escape. So you can see in the picture on the right-hand side here, this is the result of what's called the greenhouse effect. And we'll talk through a little bit of what that means in a minute. But basically what happens is the sun is obviously releasing its radiation, and that solar radiation makes its way into our entire solar system, but it also comes and makes its way here. That radiation, 50% of it, as Ms. Case just mentioned, makes its way to our planet, gets absorbed by the ground and other structures on the planet. And then usually at nighttime, it gets re-radiated. So it gets re-released back out from the ground and other objects and goes back up towards the atmosphere. And so what happens is different molecules in the atmosphere, different compounds, different gases, are going to either trap that heat, so bounce it back down, or sometimes some of that heat will escape and make its way back into space. And that's what you can see with these kind of bouncing arrows, right? Solar radiation coming in, getting absorbed, and then bouncing back into space, some of it being reflected or scattered, as Ms. Case mentioned. And then that re-radiated heat either escaping back into space or getting bounced back down by our wonderful atmosphere. And again, oops, I hate when the thing pops up. The analogy we have for you, it's not the best one and it's not totally accurate, but think about you get cold, you're sitting in your house, maybe in your basement on the couch or something, and you put on a blanket. All right, you put on that blanket and right away you're still kind of cold, but over time, underneath that blanket, it starts to get really warm. And that's because your body is releasing heat. And that heat that's getting released is getting trapped by the blanket that is around your body. And so it creates this kind of nice cushion of warm air around your body, which makes you feel warmer. And that's pretty much how our atmosphere operates. So the question is it a good thing to trap heat? Well, the natural greenhouse effect, so this process happening without extra compounds or more components, is good. All right, this is what allows for Earth to be habitable. It allows this planet to have liquid water. It allows us to have an average global temperature, in the low 60s, upper 70s. It allows for the abundance of life that we see on our planet. And so that's a good thing. All right, it allows us to keep that habitable temperature. Some of those natural greenhouse gases that are helpful to that are primarily water vapor, so that's H2O in its gas form, carbon dioxide, CO2, which I'm sure you've heard a lot about relating to climate change, which we'll get to in a minute, and methane. All right, those are probably our three most prominent natural greenhouse gases, so gases that are already in the atmosphere as a result of different chemical reactions happening here on Earth. So again, that solar radiation is able to enter, get absorbed, get re-radiated back out, and then get trapped by that atmosphere, right? Because there is a set amount of those gases in the atmosphere. But If we overload the atmosphere with more of any of these gases, the one we've pretty much put a lot into the atmosphere, at least in the last 200 years, is carbon dioxide. But if we overload with these or with some of these man-made greenhouse gases, gases that we have created as byproducts of industry, chemical reactions to make products that we use, those get released into the atmosphere and they fill that up. In other words, they kind of fill up the empty spaces where heat was escaping. So some of that heat, remember, was leaving, was escaping. Those arrows were shooting back out into space. And that's good because we don't want to trap all the heat, right? You wear that blanket for long enough and you're starting to scoot it and get your feet out because they're hot, or you're starting to put your arms over the blanket, or eventually maybe you take the blanket off because it gets really, really warm. All right, so the more man-made gases we added to the atmosphere, and you could see even their names kind of look a little scary, right? Chlorofluorocarbons, perfluorocarbons, hydrofluorocarbons. So they're just scary words. They're not really, they're just telling you what chemicals are in there, but they sound very complex and they start to fill up the atmosphere along with the extra carbon dioxide, the extra methane gas that has filled that space. And what that has done is allowed less heat to escape, thus trapping more heat. And over time, that has created an increase in the global average temperatures. And when we look at the numbers, it's a degree or two, but the difference between 1 or 2 degrees on a global scale is a significant concern for small weather events, which we tend to see all over the world. And that is what Ms. Case is going to talk about when we refer to the concept of climate change.
So during climate changes, we've got places are becoming colder or warmer or even wetter and drier. Glaciers are starting to melt. And as a result of this, it is leading to our ocean levels rising, causing flooding and erosion to occur. This also impacts agricultural areas. So people who are farming, and it's causing, these higher temperatures are causing their soil to dry up, to be moved around by the wind, and causing difficulty for them to grow their crops. The paths of our ocean and currents or air currents shift because, and that this is causing the parts of the world to be cooler. So as some of those climate changes are occurring, one small impact from one of these areas can impact a majority and kind of cause a trickle effect on the rest of our system here. So that's kind of what this picture is about. We've got changes in any kind of atmospheric composition. Any changes in the ocean circulation is causing, different interactions that are happening maybe within that ocean. And then how does climate change impact us as humans? So I really like this graphic here, because as you go through and take a look at some of these climate changes that are happening, you can see what type of health impacts we might have as a result. So if we were to take a look at air pollution, right? If we have an increase in air pollution because of our climate change, that's going to increase people with asthma and their cardiovascular diseases. Increasing in allergens, that's going to also increase allergies and respiratory issues as well as asthma. Environmental, right? We've got forcing migration and civil conflict type things happening, as well as mental health impacts. Extreme heat, right? We might have heat-related illnesses, deaths, as well as severe weather causing injuries, fatalities, mental health impacts as well. So it's not just affecting our outside weather on the daily basis or the overall climate, but the changes in this also affect our health concerns that we may end up getting.
And just to jump in as well, you can see in the center, it kind of gives you an idea of what aspects of climate change are causing those bigger picture environmental and weather issues. And then, as this case pointed out, all those different, what are kind of like parts of our life, right? How we feel, are we happy? Are we sad? Are we healthy? Are we sick? Are we in a place that's safe? Are we not? Those are all, ramifications of the same things, extreme weather events, rising sea levels, increased CO2 levels, rising temperatures. All of those climate change features impact all of these pieces here. And especially just because of the year we have had, these changes in vector ecology, what that means, I know, again, words that maybe we're not familiar with, but a vector is like a virus or a bacteria. So when you have extreme weather events, that can result in temperatures that become more comfortable for certain viruses and certain bacterium to be able to survive longer in those cases, or the flip side, maybe to survive, less. But something that obviously is something being talked about, especially in our current pandemic, because obviously we're dealing with new viruses, SARS-CoV-2 that's causing COVID-19. And so we see these different viruses kind of making their way into our world. And there could be ties to the fact that it's easier for them to live because of certain temperatures in certain parts of the world that have changed because our climate is being adjusted. So again, it's more than just the weather outside. It's more than just extra snow. It impacts us in a variety of ways. So as Ms. Kay said, I also really like this graphic. Make sure you take a good look at it.
And so what are some ways that we can combat this change of our climate? We need to start by lowering these greenhouse gases. And in order to do that, we need to take multiple different approaches. Just doing one will help, but doing a few things at the same time will definitely help that lower. So some of our key solutions would be reducing our fossil fuel emissions. So that could be renewable energy sources, putting on a solar panel, hybrid or electric cars, riding a bike to work instead of driving a car, walking instead of driving a car, right? Anything that you can do to lower those emissions from a car. Recycling is a great way as well. And one of the things I've always wanted to try is food composting, right? So not throwing away your trash, your food as trash, but maybe using it as compost and creating more dirt and things that you're going to be able to utilize in your house.